We left off on number 3. Let's go to number 4. All right. Remember, this is the H, A, and K. So here's the base. 4 is our base. So here I have 1/4, 1, and 4. So let's see what we have. We have an H. So the H is plus 1, so we're going to subtract 1. And we have a K. So we're going to subtract 1 from that side. So let's do the H first. So -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. Okay, let's go to the Y side. So I'm going to subtract 1. 1/4 minus 1 is -3/4. 1 minus 1 is 0. 4 minus 1 is 3. Okay, so I have a K. So that means that our asymptote is going to be y equals -1. So right here, right there. Okay, so now let's plot our points. So I have -2, -3/4 right here, and I have -1, 0 right here. Then I have 0, 3. So I'm pretty close to that, but never touch. And there's our exponential function. So again, our domain is -infinity, infinity. Our range will be the asymptote, so it's -1, infinity. What else are we missing? Oh, the y-intercept. We're lucky enough to have exact here, so 0, 3. And the transformations that occurred from the parent are, so we are shifting left 1, because that's opposite of H, shift left 1. And then the K is a shift down 1. There we go. All right. Number 5. So the H is over here, the A and K here. Our base is 2, so I have 1/2, 1, and 2 that we're going to work with. So we have an H and we have a K. Our H is -4, so I'm going to, oops, go back. I'm going to add 4. So -1 plus 4 gets me to 3. 0 plus 4 is 4. 1 plus 4 is 5. Let's see. I have an A of -1, so we're going to multiply by -1, and K, so we're going to add 2. So lots of stuff going on here. So if I multiply a half by -1, I have -1/2. And if I add 2, I have +1/2. 1 times -1 is -1, plus 2 is +1. 2 times -1 is -2, plus 2 puts this right at 0. Again, I have an asymptote here, and it's the K, so y equals 2. So there it is right there. There's your boundary. Let's plot. So I have 1, 2, 3, and 1/2, which is right here. 4, 1, 5, 0. So this, curve it around like that. There you go. Domain, again, -infinity, infinity. My range is -infinity, 2. And remember, those are still parentheses because you're not going to touch it. And then the y-intercept. Let's see how we get that. We're going to plug in 0 for x. -2 times 4 to the, oops, I'm doing the wrong one. Sorry. -2 times 0 minus 4 plus 2, which gives me negative 2 to the power of negative 4 plus 2. So negative 1 over 2 to the 4th plus 2, which is negative 1/16 plus 2, holy cow, which gives me 1 and 15/16. Yikers. So 1 and 15/16 and 0. Holy cow. All right, transformations. See what we got. That negative sign gives me a reflection over the x-axis, the negative a. And then we have the h. So it's negative, so that's a shift right of 4. We go opposite. Then shift up 2 because the k is positive 2. All right, let's look at one more topic. All right, it says when given data, whether as a graph or in a table, determine the constant ratio and the initial value to write the equation. So let's look at this. When you have an exponential function, you know that the y values are multiplied by a common ratio. Okay, so if you look at the y values, look at this, times 2 every time. Every time. And here, we're adding 1 to the x values. All right, so we're going to use the parent equation, which is this, to find the equation. So the first thing you're going to do is you're going to, I'm going to use 0/16 to find a. I'm going to plug those in for x and y. So I have 16 equals a to the b power all to the 0. Anything to the 0 power is 1, right? So a is 16 times a times 1, so a is equal to 16. Then I'm going to use that I have a, so now I'm going to use 1 and 32 to find my base. I'm going to use a as 16, so I'm going to plug in 32 for y, and I found my a, so I have 16 times b, we don't know b, and I know when it paired up with 32, my b is 1. So b to the first power is b. So I have 32 equals 16b, and when I divide by 16, my base is 2. So now I can plug that information in, and my equation is y equals a is 16, my base is 2 to the x power. So you solved once using one of the points to get a, then you solved again using another point to get the b, and we plugged our information in to get the equation. All right, so let's look at the next one. So my y's are increasing by 1, or my x's, sorry, are increasing by 1. And then the common ratio here is you're multiplying by a half, times a half, times a half, all the way down. Okay, so let's do the same thing. We're going to use the parent. And first, I am going to use 12 and a half and 0 because that 0 power makes everything 1. So I'm going to plug in 12 and a half for y, and I have a b to the 0 power. So now a is 12 and a half. Okay, so now I'm going to use a different set of points. I'm going to use 25 and negative 1 to plug in again. I know what a is now, so I have 12 and a half. I'm sorry, 25 goes in for y. Sorry, 25 equals. Now I'm going to put in the 12 and a half I just solved for. And then I have b to the negative first power. Okay, so now I have this. 12 and a half times 1 over b. So I'm going to multiply each side by b to clear the b out of there. So I have 25b equals 12 and a half. And I know it's a lot of moving back and forth. When I divide by 25, 12 and a half divided by 25 is a half, or 0.5. So now let's plug in. So my equation is y equals, now my 12 and a half that I solved first for a, and inside of here is my base, which is 1/2 to the x power. Yep, it's a lot going on, I know. All right, so here are some facts, some summary facts. There's a lot more things, but these are the things to pull out of this. Linear functions have a common difference. If they were on a table, you'd see a common difference in the y values. Exponential functions have a common ratio. That means the y values are multiplied by the same value. Absolute value functions have a vertex, while exponential functions do not. All right, that's it.